Hey everyone, notes 4.1 are on solving quadratic equations by factoring. And before we do that, I want to look at these first few questions right here. So the directions say to find the values of C and D that satisfy each of the following equations. And there may be more than one correct answer. So in number one, it tells you that C times D equals 0. So if I have two terms or expressions that multiply together to give us 0, that means that either C equals 0 or D equals 0. Okay? And if C is 0, D could be anything. And if D is 0, then C could be anything. But no matter what, one of them has to be 0. So in number two, this one's a little bit trickier because in number two, it's saying that D times C minus 5 is equal to 2. So here I have two different expressions being multiplied together. The first one is D, and then the second one is this C minus 5. And when I multiply those two numbers together, I get 2. Well, if I do it like this, then I can say that D equals 2, for example, and that C minus 5 equals 1, because if I multiply 2 by 1, I would get 2. But I've got other options too. I could also say, for example, that D equals negative 2, and that C minus 5 would equal negative 1, because a negative times a negative is a positive. But we're not just limited to this, right? We could also mix and match and say that D equals 1, C minus 5 equals 2. Or we could say that D equals negative 1 and C minus 5 equals negative 2. Again, because these values multiply together to give us this 2 that we're looking for. And then a lot of us will say, that's it, those are the only combinations, except they're not the only combinations. I could also say, for example, D is 4, and that C minus D is a half, because 4 times a half is still 2. I could say that D is 8, and C minus D is equal to 1/4. 8 times a fourth is 2. I could say that D is 800. And that C minus 5, sorry, this should have said C minus 5 right here, would be equal to 1 over 400, right? I've got so many different ways that I could get values that equal 2. In fact, there are infinite possibilities of ways that I could get these two values to equal 2. So for this, I can't really conclude anything other than the fact that the two numbers have to multiply together to give us 2, but there's really no conclusion, right? I can choose any number I want for D. Okay, and as long as C minus 5 is equal to 2 over D, then I can always find a value for C minus 5. However, for this right here in this expression, I've got still C minus 5, and that's being multiplied by D, and that equals 0. And I can make a definite conclusion that either C minus 5 is 0 or D equals 0. And if C minus 5 equals 0, then C would have to be 5 or D would have to be 0. Like, this is a definite conclusion that I can make. And it works because when I plug in 5 here, 5 minus 5 times D, I don't really care what D is in this scenario, I would end up getting 0D, which is equal to 0. That is true. Or if I plug in 0 for D right here, I would still end up getting 0 times something. Doesn't matter what that C minus 5 is, and you get 0. So this is a definite conclusion. Which brings us to the zero product rule, which tells us if A and B are two numbers or two expressions and A times B equals 0, then either A equals 0 or B equals 0. If anything multiplies together to give us 0, one of these things has to be 0. And we've talked about this before, but I can't stress this enough because you have to understand why we're doing what we're doing instead of just kind of following a process. So now we need to talk about the difference between linear and quadratic equations. So a linear equation is an equation with a degree of 1. So an example would be like 5x plus 8 equals 2x plus 7. If you notice right here, this is all to the power of 1. That's the highest exponent. And when we solve this, the number of possible solutions we can get is 1. It is not a coincidence that the degree is the same. So for example, here I would get 5x plus 8 equals 2x plus 7. And then to solve, we always get the variables on one side and the constants on the other. So for example, if I have this equation that I have up here, 5x plus 8 equals 2x plus 7, we would move the 2x on this side, move the 8 on this side. So you would get 3x equals -1, which means x is -1/3. But if you notice right here, I got the variables on the left side. It doesn't matter what side you get it on. But my constants are on the other side of the variables before I went through and I did my division. It's different when you have a quadratic equation. So in a quadratic equation, the degree is 2. An example would be like x squared plus 5x plus 6 equals 0. If you notice right here, this is to the power of 2, and the highest number of solutions you can get is 2. Again, not a coincidence that those are the same. Doesn't necessarily mean you'll get 2 solutions. Sometimes you'll get 1, sometimes you'll get none, but the maximum number of solutions you can get is 2. To solve this, we have different ways of solving. We could either solve by factoring, which is what we're going to learn about today, or we could do something called completing the square, which we'll learn about later on this unit, or we could use a formula called the quadratic formula. But the key piece today with this factoring is that unlike our linear equations where we get the variables on one side and the constants on the other side, for factoring, we have to get everything on one side and then we should have 0 on the other side. Okay, we're setting everything on one side equal to 0. And that's where this zero product rule is going to come in. Okay, so what does this all mean? How do I apply this? Let's look at number 1. So in number 1, I'm trying to solve this by factoring, and it has to equal 0, which we have here. So I'm going to go ahead and factor this expression right here. And I'm going to use guess and check for this factoring because the leading coefficient is 1 and it's a lot easier. I know that the first two terms, when I multiply them together, should give me x squared, this right here. And the only way I can get them to multiply together to give me x squared is by using x and x. I also know that the last two terms should multiply together to give us this 10 right here, the c value. So I'm going to list out factors of 10. So I could either use 1 and 10 or 2 and 5. I'm going to try 2 and 5 because I see a -7 here, and it looks like it would be promising to be able to get these values here. You don't have to write this next part down quite yet because we'll need the space here. But if you notice here, we've got 5x and 2x, and if they're both negatives, then my answer will work here. The goal for these kinds of questions is for you to not need these little carrots anymore and to be able to just get these answers easily. So from now on, if you're able to do it without the carrots, that'd be awesome. Okay? Now, what was the point of this? Why did we even want this set equal to 0? Because now we have one expression being multiplied by a second expression, and together they multiply together to give us 0, which means that either the first expression will equal 0 or the second expression will equal 0. To solve this first expression here, I would add 2 to both sides. To solve this second expression here, I would add 5 to both sides, which means that my two solutions are 2 and 5. Now, really quickly, the reason why this works is because when I plug 2 in right here, 2 minus 2 is 0. 0 times anything, I don't really care what it is, will still give me 0. And if I plug in this 5 right here into this set of brackets right here, even when I plug it in here, I don't really care what that gives me because this gives me 0, and 0 times anything will always give me the number 0. And that's how you solve a quadratic equation by factoring. So in this next example, pay very close attention because a lot of people are going to say, oh, I've got two things that multiply together to give me 30. I can say that the first one, either the first one would equal 30. Don't write this down because this is so wrong. Or the second one would equal 30. But this is incorrect because if you remember, numbers that we can multiply together to give us 30 are multiple options. We could do 1 and 30. We could do 2 and 15. We could do 3 and 10. We could do 5 and 6. We could do negatives of all these values. And nothing says that these values are not allowed, these expressions here are not allowed to be fractions or decimals. So I could use like 1/2 and 60. I could use 1/10 and 300. I mean, I've got infinite possibilities. So you don't want to do it this way. We have to have 0 on the end. So I do want you to write down right here that this is not 0. So we cannot do our set each factor equal to whatever number that we have here. So to get this 30 out of here, I need to subtract this 30, right? So I would have x plus 5 multiplied by x minus 8, and then I would subtract the 30 from the other side, and now I have 0. But I have to expand this and simplify before I can actually move forward. So here this is going to feel a little counterintuitive because we're going to expand, simplify, and then we're going to factor, which are opposites of each other. But that's because this minus 30, we got to bring that into the happy family inside of here. We can't just leave it out. So when I expand and I simplify right here, I'm going to do x times x, which is x squared, x times negative 8, which is negative 8x, 5 times x, which is 5x, and then 5 times negative 8, which is negative 40. Then I'm just going to copy down this minus 30 equals 0. Now, if you see right here, I have some like terms I can put together. So negative 40 minus 30 is negative 70. So I've got x squared, also negative 8x plus 5x is negative 3x. I can put those together and that will equal 0. Now that I've got a quadratic that can equal 0, I need to factor my quadratic, okay? So I'm going to see what multiplied by itself will give me x squared, and that'll be x and x. What times itself will give me 70. And I can use 10 times 7. And I want that because this would be a negative 10 and a positive 7 will give us the negative 3 that we're looking for. So if you see here, this gives us the 7x that we want. This gives us the negative 10x that we want. And together they give us the negative 3x that we are looking for. So now I can go ahead and set each factor equal to 0. So I'm going to say x minus 10 equals 0, and then I'm also going to say x plus 7 equals 0. So to solve for x here, I would add 10 to both sides. To solve for x here, I would add negative 7 to both sides. So that means that the solution would be 10 and negative 7. All right, and number 3, the exact same idea. So this is not 0, so I can't factor this quite yet. I can't solve this quite yet. A lot of people will try to divide by x, which you cannot do because if x is 0, you're dividing by 0 and that's not allowed. So anytime you have an x squared, you have to get everything on one side. Just a reminder, we also want to get everything on the side that's going to make our leading coefficient positive. So because our leading coefficient is positive already on the left side, I'm going to keep this on the left side and I'm going to get rid of the 7x. I'm going to move it over. So I'm going to subtract 7x and I get 0. Now, just a reminder, now that we're ready to factor, the first question you always ask yourself whenever you factor is there a GCF? So I'm going to factor out a GCF, which is x. There's something in common. There's an x in common. So then when I factor it out of x squared, I get x. When I factor it out of negative 7x, I get negative 7. And then I set that equal to 0. Now I'm at a point where I have two terms multiplied together to equal 0. So that means x would either equal 0 right here, and that's nice and easy. It's done already for us. Or x minus 7 equals 0. Here I can add the 7 to both sides and I get positive 7, which means my solution is 0 and 7. All right, and number 4, we have negative 6x squared minus 12 equals negative 27x. So right here I have a leading coefficient that is negative. And I have terms on both sides, so I need to put everything on one side. And I don't want to keep it on the left side because it's negative. So I'm going to move the minus 6x squared over, and it will become a positive 6x squared. But that also means that I have to move the negative, get rid of the negative 12. I want to move it over here. So I'm going to copy down this minus 27x, and then I'm just going to write down that this becomes a positive 12 because I would add the 12 to both sides, right? Which leaves me with 0 on the left side. The reason why I put it in this order is because this is in descending order, and if it is not in descending order, if I were to write it out like this right here, then the factoring would be significantly harder to do. So now I'm ready to factor. And the first question I always ask myself whenever I factor is there a GCF? Is there anything in common with these three terms? And I can see that they're all divisible by 3. So when I take out a 3, I have 2x squared left over. When I take it out of this minus 27x, I get minus 9x left over. And when I take it out of this 12, I get a 4 left over. You may have wanted to go straight to factoring here, but it's so much easier to take out that GCF and do your factoring with this. Now I'm going to use decomposition this time for those of you that that prefer decomposition. So I'm going to copy the 3 down. Now, just a reminder, to do decomposition, I have to multiply the A value by the C value. So I'm going to multiply 2 times 4 and I get 8. Then I'm going to make a chart for 8. So I can either do 1 times 8 or 2 times 4. They need to add up to give me negative 9x. So I'm going to use 1 and 8, but I'm going to use double negatives here. So negative 1 and negative 8 give us negative 9x when we add them together. But check to make sure they give us the number that we're looking for, which is a positive 8, and it does. So I'll copy down this 2x squared. Then I can write here minus 1x or minus x minus 8x plus 4. By the way, if you prefer guess and check, just go ahead and try it and then come back and see if you get the same answer as me. Okay, so I get 0 equals 3. Now I have to group a bunch of terms together. So here there is an x in common with both terms, and that's it. When I factor it out, I get 2x minus 1. And then in here, we have a negative value, which means I'm going to factor out a negative, and there is a 4 in common right here. So when I factor it out, I get positive 2x and minus 1. Don't forget to always copy down that 3. Now I can see here that there are 2x minus 1 in common, and we also have x minus 4 in common. Okay. Now I factored it, I'm ready to set each part equal to 0. Now pay really close attention here because we have actually 3 expressions that are multiplied together. We have the 3, we have the 2x minus 1, and we also have the x minus 4. So I'm going to set each part equal to 0. So I'm going to say 3 equals 0, which is not true. 3 will never equal 0. So I can completely ignore that 3. I would set 2x minus 1 equals 0. This is another spot where people will mess up. Be very careful. I get rid of the 1 by adding 1, but I still have to divide by 2 to get this x alone, which means x is 1/2. And then for this last one right here, I would say x minus 4 equals 0, add the 4 to both sides, so x equals 4, which means that my two solutions are x equals 4 and x equals 1/2. Because these are both solutions for the same variable, I use my squiggly brackets to indicate this is a set of solutions, and these are my answers here. One last thing I just want to say before we end this video is that this right here, another option you have is just to divide by 3, and then 0 divided by 3 is 0, and then you can just set each part equal to 0, just like we did before, and you just don't even have to worry about this piece at all. Okay, you can think about it either way. It doesn't really matter. As long as what is in front right here does not have a variable with it. If it does, then it would look more like this, and you have to set that variable equal to 0. All right, that's it for this video. Let me know if you have any questions. Otherwise, we'll just plug along. See you later. Bye.